Hello and welcome back to this Fundamentals of Machine Learning tutorial. In this fourth lab session, we'll look at linear regression. So you can set up your environments. So simply open Google Colab and create a new notebook. So you can click on File and then New Notebook. So we'll start by importing necessary libraries. Libraries are a collection of functions and methods that allow you to perform many actions without writing your code. We have NumPy, which we've used before, a library for the Python programming language, adding support for large multidimensional arrays and matrices, along with a large collection of high-level mathematical functions to operate on these arrays. We also have Pandas, which is an open-source data manipulation and analysis library built on top of the Python programming language. Matplotlib, a plotting library for creating static, interactive, and animated visualizations in Python. And scikit-learn, a simple and efficient tool for predictive data analysis built on NumPy, Skippy, and Matplotlib. So we've used about 3 of this before, and we'll continue along as we go. So we have the first one, import NumPy as NP. So if you recall, this is an alias. Instead of typing NumPy every time, we can use NP. Same goes for PD and PLT. Then we have from sklearn.model selection, we want to import train test splits. And this is useful because it splits our data set into 2 parts. One part for training your model and one part for testing it. So it's useful because it helps you see how well your model can handle new unseen data after it's been trained. Imagine you have 100 photos. The train test split might use 80 photos to teach your model how to recognize objects and keep 20 photos aside to test how well the model can recognize objects it hasn't seen before. And in this particular tutorial, we'll be using linear regression. From sklearn.linear model, we need to import linear regression. And we'll need to also import mean squared error. We want to see the error in what we are doing. So remember from the previous, the linear regression video, we want our error to be close to 0 to show it doesn't really have much error. So now let's load the data. For now, we'll create our own data set. So this is how it will typically look like when loaded from a database or a file. So let's create one within the notebook that might mimic a real estate data where you predict house prices based on size and numbers of bedrooms. So from the previous slide, we created a data frame. So instead of name, age, and city, we'll be using like a real estate example. So we have square feet, bedroom, and price. So when a house is 1,500 square feet and has 3 bedrooms, the price should be 400,000. 1,800 square feet, 4 bedrooms, price 500,000. So same way. So let's put this now. First, let's import. So paste the code here and run it. So let's open another code block while that's running. So let's get this data. So in our variable data, we have a data frame. So remember your dictionary and list from the previous tutorial. So square feet, and this will be the rows under the square feet column. So let's run this. And when we run this, let's print data since it's stored in the variable data. So here you go. We have square feet, so this column has 5 rows representing this. So when the first house, remember we start from 0, when the first house, 1,500 square feet, 3 bedroom, the price 400,000, and so on. So we've created our own data sets, which we'll start with in this tutorial. So let's try to visualize our data sets. Let's pair square feet and price. So remember scatter plots, it shows different points. Let's run this code. So plot.scatter, we want the square feet, the price, the color to be blue, and the label is square feet. The title, house price, the X label, which is the horizontal axis, should show square feet, and Y axis should show price. So here you have your title, here you have the general label, the X label, square feet, the Y label, price. So this is how we can plot it. So remember when our house was 15 square feet, 1500 square feet, the price was $400,000. If you notice here, 1500 square feet, 400,000. So now let's do the same thing for the bedrooms. So create a new code block, this here. Also, plot.show is just to show the plots. So remember we are using PLT because that is our alias for matplotlib or pyplot. So instead of typing this long word here, you simply just need to write PLT. So let's run this too. Same here. So we have 3 bedrooms, price 400,000. Let me show you. So 3 bedrooms, price 400,000. So remember, different features can also lead to the price. So that is why when you also see 3 bedrooms, 600,000, but because the square feet of this particular house is higher, that's why it's 600,000. So different features can give you another output. So prepare data for training. So data splitting, you split your data set into training and test set. The training set is used to train the model, and the test set is used to evaluate how well your model performs on unseen data. So remember our data frame is stored in a variable called data. And we have 3 different columns. We have square feet, bedrooms, and price. So if what you want is to use square feet and bedrooms to be able to predict a house price, that means this will be your input. Square feet and bedrooms will be your inputs. And it's commonly stored in a variable called x. So you can name this what you want. For example, you can name it inputs. So what we're trying to do, the features should go in one variable x, while the target, what you are trying to predict, should go as the target outputs, here, depicted as y in our case. So remember, you can select different columns. So data square brackets, and then you have square feet, one of the columns you want to select bedrooms. So from your data, it's going to get these 2 columns and store it in X, and it's going to get the price column and store it in Y. So remember from our previous tutorial. So now, the next thing we have is train test split. So remember, train test split to split your data set into 2 parts. So one part for training your model and one part for testing it. So we have here, when you put train test splits, you put this input, which is x, and the output y. Then test size, what split do you want? So in our case here, it's 0.2, which means the test set should be 20%. And random states, make sure you get the same reproducible split every time. So let's take this. So there. So now that we have our test set of 20%, if we had 100 data, it means our test size will be 20 and our train size will be 80. But in our case where we have 5 rows, like in this case here, it means it will take 4 for training and 1 for testing, because 20% of this 5 is just 1. So it will take only one of these rows depending on the one it decides to pick, and the remaining 4 will be left for training. So that's what you have here. So the training is just basically like saying, for this square feet and this bedroom, you tell it this is the price of the house. So let's take our model to try and create and train the model. So linear regression, remember, it's a statistical model that attempts to model the relationship between two variables by fitting a linear equation to observed data. Here you train the model using the fit method. Here, just like this. So let's run this. So what fit does is it trains your model using the training data. So it's how the model learns from the data you give it. So let's go back to our photo example. So let's say after splitting your photos, you use the training set 80 photos to teach your model. So this step adjusts the model so it knows how to identify objects based on those 80 photos. In our case now, it's going to pick 4 of this and it's going to teach the model. So it's going to tell the model when a house is 15 square feet and has 3 bedrooms, the price is 400,000. When a house is 1/8 and has 4 bedrooms, 500,000, 2 4 square feet, 3 bedrooms, 600,000. So this is what it will do for 4 of these rows, and it will leave only 1 for testing. So now let's try to predict and evaluate and see if it has learned. And we'll also try to get the mean squared error, the error we receive. So we have model that predicts here, X test. So remember the reason that fit has 2, because you want to teach it along with the answers. While when you're predicting, you just want to give it the question or the example and it should give you the correct answer to predict the correct answer. So you use .predict to train so it uses the trained model to make predictions on new data. So you can see how well the model can identify or predict based on what it has learned. So let's go back to the photo example. After training with the 80 photos, you use the model to predict what's in the remaining 20 photos. The model tries to recognize objects in these new photos based on its training. So in our case, the one that's been left out will be used to evaluate. Let's see. So here we have a pretty high mean squared error. Let's see what our X test was, Y test was, and what it predicted. So let's try to print out X test. And print out Y square peg. So our X test was 1804. So when it was splitting our data set, it chose this and the last 3 in X train, without the price parts, and it left this particular one for testing. So this was X test and this was Y test. So remember, it will have to keep the answer somewhere else, but it will not show the model when the model is trying to predict. So X test 1800, the actual price of the house is 500,000, which is Y test if you look at the row again. And it predicted that the price of the house was 459,525.66 and so on. So this means that it was kind of off because the price of the house should be 500,000 and this should be 500,000, or at least very close to 500,000. So one reason for this is because we don't have enough data for it to properly learn. So now let's try to use let's plot this first and then try to use a real life data. So we can just visualize it. So this is just a way to plot the actual versus predicted prices, and it helps just visually assess how close the predictions are to the actual prices. So same plot the scatter, and then you can run it. So after this, so you can see that here. So actual price 500,000 is 46,000. But currently in our data set, we just have one. So that's why you can only see one scatter plot here. One dot here. So let's go to a real life data set here. So let's use the California housing data set. So it's still the same thing, the same way here. So import. So we can create a new notebook. Okay, let's just continue with this one. It's a new notebook here. So we have the imports, but we actually do not need this. We've already imported it in this particular one. So we have train test split and mean squared error as well. And we have linear regression. So we just need to import these two. Okay. So now we've loaded the California dataset. So this dataset includes metrics such as median income, housing average age, average rooms, average bedroom population, average occupancy, latitude and longitude, all of which are predictive of median house values. So let's load this in a variable called housing. So we'll load the California dataset in a variable called housing. So remember x, simply just the input variable. So if you look at the documentation for the California housing dataset, you'll see you need to put this one, housing.data has the x values, while housing.target has the y values. So the inputs here and the actual outputs here. So we'll also print x.head. So remember x.head from the previous example, it will show the columns and the first 5 rows, and we'll also have y, which is the answers to the first 5 rows. So let's take this. So let's run this. So here you have the x here for what our input will be. So the same way we had number of bedrooms and square feet, here we have all of this here, from average bedroom population, average occupancy, latitude, and so on. And this here is the answer to these rows. So now let's process our data sets. So same way. So let's check for missing values if you remember previously. So let's print out all of the ones that are null, and also let's feature scale our data sets. So you can check the data processing video to recall data processing steps. Okay, so currently we don't have any null values. All of the values So when we summed up all the null values, remember that is null will check in this x, what are they is null, and it will sum them up. So currently we don't have any null values. And the next thing we did was just to scale our x. So we'll split the data set again. So remember training and testing. So after we train it, we'll want to see how well our model is doing. So that's why we need train test. So remember our model, linear regression, so still the same way with everything. So now let's make predictions and see our mean squared error. So yeah, so a much better mean squared error than the previous one. So remember you want your error to be 0 or close to 0. So really close to 0. So you may not always have a perfect data set. So it will be very hard for you to get 0. But normally it should be very close to 0, 0 0.1, 0 0.01, etc. So you can also visualize the actual and predicted value like we did previously, and you can show the line. So remember logistic regression, you're trying to fit a line through a set of points. So I'll take this one first. Paste it. Take this one. Okay, let me complete this part. This way. So just like this. So can you see the line? This is pretty okay. So it kind of fits this points well. So that is all from our logistic regression tutorial. So it just guides you through using the California housing data set to train a linear regression model from data loading to model evaluation. So you should know how to create your own data for linear regression, and now you've learned how to use a real world data for linear regression as well. So thank you for watching. I'll see you in the next video.